Good day everybody and welcome back to the channel. I was just doing a visual inspection because I'm about to power his boards up for setup, and I discovered something that just made me laugh. I've installed every single LED upside down. I don't even know how I did that. I guess it was because I was talking on camera whilst I was doing it. I just wasn't actually thinking about what I was really doing. But anyway, every single LED is upside down. So I'm just correcting that, and then I'll continue having a look over just to make sure that nothing else is installed the wrong way around, and if everything else is correct, we'll power it up. I think what I'm going to do, I've been thinking about this, I put a lot of thought into this. We're going to set the VAS current for 6 milliamps and leave the input pair at 4 milliamps at the moment. So I just want to see how that works to start off with. I think 4 milliamps for the VAS is a little bit low. Well, these are triple Darlington. I'll leave it how it is. I'll leave it how it is for now, and we'll see. I can't remember if I flowed solder in here. Oh, they look shiny. No, I'm going to touch a couple of those up. So anyway, I'll get these touched up quickly off camera, and we'll get into this. Silly shit I do. Alright, so now the LEDs are all installed the correct way around. Actually, you know what? I forgot to check the input pairs and current mirrors. My bad. I've checked the transistors, the correct transistors, but I just need to double check the actual trace layout and make sure that that was right, because there was a few things I had to change when I was populating the board. So I'll just go over that now. Sorry, my apologies. I made a mistake in the way I explained this. I've been reading up on two-pole compensation and output inclusive compensation, and when I designed all this, I changed the compensation network over the VAS to this. I thought this was two-pole. This is output inclusive. I mean, I knew it was output inclusive because it goes back into the feedback network, but I thought because there were two capacitors here separated at this midpoint going back, that was also two-pole. Apparently it goes to the negative rail or something like that. So this is output inclusive compensation. I actually got something on the screen I can show you guys just quickly. I'll just bring this back up to where I started reading. So yeah. I'll just scroll down and pause in places so that if anyone wants to read this, they can pause and have a quick read. But this is what I am getting my head around at the moment. So that's what I've done with my amp, like this. So now we're looking at two-pole compensation. As you can see, there's a resistor going down to ground, and the first capacitor is actually a larger value than the second one. Oh, no, that's still the same, yeah. Hmm. Alright, that's enough for now, I guess. So, if anyone wanted to know, that's out of Doug Sell's 6th edition Power Amplifier Design Handbook. I might have a look at that, adding that capacitor as well. I'm curious, I'm just going to scroll back up because I noticed a section where it was talking about combining two-pole and output inclusive. Let me just read what he's got to say there. I might do that. I might order some 10 picofarad capacitors and experiment and see what happens if I attach one from this point here to the 0-volt rail. So we'll see what that does. But yeah, it's going to be really tricky to do both, so I'm just going to stick with the one, and it's output inclusive compensation, not two-pole. So sorry about that, but at least now you all know. Alright, so excuse the cat on the bench, but anyway, I've done a bit of reading and research because, as you know, I am a very thorough person and I don't believe in doing a shoddy half-assed job. If I don't understand something, I will learn it. I sure as hell understand compensation. I know the difference between two-pole compensation and traditional Miller compensation and output included compensation. But where I'm getting confused, well, originally I was confused on the capacitor values, but I've worked that out now. So let me just put one thing out in the open. These two caps here, C1 and C2, we'll call them. The second cap should be 5 to 10 times larger than the first cap if you're doing two-pole compensation. If you're doing output inclusive compensation, they should both be the same value. Now, the way I've got this set up is output inclusive, and these aren't the same value. So just remember that with what I'm about to go into. So, and ignore that. Just ignore that for a sec, otherwise you'll get confused. So, oh shit, sorry. So as you can see, it's supposed to be set up. This is the circuit I've got basically. got the two caps here, resistor off the center point going to my feedback node. Now I've got a 560 ohm resistor here, and I've got a 470 picofarad cap here and a 47 here. So, it's about 40. I measured it, it's like 44 picofarads from end to end, something like that. Which is what I want. But I did some reading in here to see if there was anything on combining the two together, because that's the best way of doing it. And I can see that with the two-pole compensation, and let me point something else out. A much better way of doing this is to tie this to the 0 volt rail, not the negative volt rail, but it depends on the topology of the amplifier. Some amplifiers you can't do that. It affects power supply, rejection ratio, and something else I've forgotten. Anyway, note that the first cap is larger, as I was saying, about 10 times larger. Okay, so even here, hey, down. Sorry, guys. Fucking hell. Sorry, I had to remove the cat off the bench. Well, not that one. And not that one, but another one. Anyway, combining two-pole and output inclusive compensation. It says here that, it would be really good, but it goes on to say that it's just really tricky, transformer coupled path for the compensation signal, blah, 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 right? It sounds like it's going to be messy. Well, I did more reading. I could only find so much in here. After reading this, I have decided I'm going to add a 10 picofarad cap from the collector of the VAS to like this, the 0 volt rail. He says 10 to 33 picofarads. 33 is the biggest he's ever seen. I don't like going too high, so I'm just going to chuck a 10 in there. Anyway. Where was it? Just bear with me. Right. So I was doing some reading on DIY audio, and someone else here pointed out two-pole compensation has inherent peaking at some frequency, which is what Doug was talking about. And yeah, adding a second resistor across the dominant pole cap, 1.4 meg is what he chose. We'll get rid of that, or help to get rid of it. Anyway, and both the capacitors should not be equal value. It should be that second one. See, it says needs to be at least 5, but 10 times bigger is better. Okay, let's continue reading. Now, someone else has mentioned that what they were talking about, there's two different things from output inclusive and transitional Miller compensation. Sorry, transitional, not traditional. And that's what I was thinking about too, because I was trying to work out if you just take the resistor, right? Let me just get my schematic for a sec. If I just take, the resistor like this to 0 volts as I drew, that makes it set up perfectly with those values in that resistor for two-pole compensation. Incidentally, making that resistor lower in value than 2.2K really helps, and I've already done that in my design choice. Anyway, my question was, okay, well, if the only difference is that going to the 0 volt rail or going to the feedback path, well, what happens with the ratios? And apparently they need to be the same if it's going back to the feedback path and you're doing the transitional Miller compensation. So I thought, well, how would it work if you're trying to do both? And I kept digging through forums, posts on the forum, shall I say. One person was like, the only difference between TPC and TMC is where the resistor is connected to. Connecting the resistor to the output, what is being referred to as open output inclusive compensation is slightly better. Output is the same. Well, I can tell you that they're wrong. Anyway, moving on. I just highlighted this because I thought this was interesting. This person has used it in all sorts of more complicated output stages, emitter followers, triple Darlingtons, all that sort of stuff. It works really good, which is really cool. And they're using output inclusive 2-pole compensation. Haha. Let's keep going. I might come back to these and get these up on screen too for you guys. But anyway, so someone's set this up, and this is we're just looking, for those of you that aren't into amps and don't know what you're looking at, that's the beta enhanced boost transistor, that's the VAS transistor. So we've got, just ignore this, this is effectively the, I guess, 10 picofarad to ground, I'm guessing. But anyway, here's our 2 caps. This person said that if they made the first cap just slightly bigger by 20 picofarad, this little bump here got flattened out, which I find interesting because, you know, it's supposed to be a much bigger ratio. But here's the thing. This is going to ground and going to the rail. So I have a feeling that we can do both, and our capacitor ratio will lean back closer towards them both being the same value if we do this. All right. Right. So next thing I want to work out, well, I want this resistor to still be 560 ohms, but it's going to go to ground. I want this resistor also, see, this is where it's tricky because the 2 resistors form a voltage divider, and in my mind I can't work out how that is going to affect the circuit. But the thing is, if especially this resistor, the lower it is in value, that comes straight off the output. So I mean, as I turn the amp up, I would just be cooking the resistor. So I mean, 2.2k and 2.2k, that makes sense. I guess smaller than 50/50 is gonna not let it do what it needs to do. So that's why they've gone like that, because, you know, 4.7k across 2 resistors, that, you know, you can dissipate the output. It'd be about a quarter of a watt or something like that, maybe 0.1, 0.2 of a watt. I can't think. My maths is bad. That's with my amp, like a 33 volt swing at the output. But anyway, so looking back at my circuit, let me just show you the rest of what I dug up first. Anyway, this guy did this and got this sort of response. So, and I've been looking through a lot. Trust me, there's a lot of stuff that I haven't taken screenshots of. I've just highlighted the biggest finds that I've had, right? So, someone else wanted to know if the transitional Miller compensation shows the same amount of closed loop gain peaking like 2-pole compensation. Apparently there is none. So what you call transitional Miller compensation has a 1-to-1 capacitor ratio, and it shows in the open loop gain plot. 2-pole compensation shows the steep roll-off as expected, but your transitional Miller compensation has shallow roll-off and looks like plain Miller compensation because the cap ratio. This person had the thing set up for TMC, but they had the 1-to-10 ratio, which is not how that works. Anyway, why did I highlight this? Yeah, that's what I was saying. That forms a voltage divider with the one connected to the output. And so that's all I've been able so far to find out, which is crazy. So I don't know what to do. So for now, I'm going to leave it because, well, there's close to 47 picofarad across where you would put normal Miller compensation. So that is working. And there's also that 500 ohm resistor connecting it to the feedback path, like the transitional Miller compensation. Now the cap ratios are off for that, but that's where I get confused. I want to implement both, but I don't get the resistor ratio and how that works and what to do about it. If anyone that's watching this video designs, high-end amps and understands this sort of thing, please either shoot me an email if you want to talk about it, or leave a comment down below, because I'm trying to work this out. What I'm thinking at the moment is, I know the 2-pole compensation is going to work really good if I just put that 560 ohm resistor to ground. So I think what I'll do is I'll do that, and then off where that 560 ohm resistor comes off of the capacitors, so off of this point here, I will put a 4.7k resistor to the output. I really don't, look, it's only, actually that's going to be divided down so much, I don't even know if that's going to work. That's going to be like an eighth of what's there. Yeah. You know what? I'm really unsure about this. I think I'm just going to leave it for now and just wait. I've put in another order today. I've ordered 10 picofarad polystyrene capacitors, 220 picofarad, 150 picofarad, 82 picofarad. I've got a few other values in between those ranges. The reason I've done that is so that when this is up and running, we can sit down and play around with these values and really see, what affects what, because this stuff's not well documented. I can't find more than what I've shown you guys on it, basically, and I've probably shown you guys more than what anyone on the internet's shown on YouTube. So this needs to be looked into more, especially when it's such a crucial part of the amplifier design. It's just, yeah, I'm going to fix that problem for you guys, for myself and for you, so stay tuned. For now, I think I'll just leave it how it is. It should be stable like that. I guess basically having the ratio not the same, for the two the same ratio, I guess that might, let's see what this person said it would do. So it just looks like normal Miller compensation. So that's why I said it works. I'm just going to leave it like that for now. All right, because there's bugger all compensation like that, which is the way we want it, and it's not going to cause any problems at all. It's just going to mean that it's not working as good as it could be. And then as soon as it's up and running, obviously, that's when I'll start putting different shaped waves into it and playing around with values and seeing what comes out of it, doing other tests and whatnot, and I'll get some definitive answers for myself and for you guys, and, we'll be there. But yeah, I can't just let this rest and just turn a blind eye to it, because it bugs me. So, yeah. All right, well, with that being said, there's nothing else I really want to do. I'm just going to do some math. I've been thinking about this already. I've been thinking about actually adding the resistor to ground. and doing that before I start putting trying to get up and running, let me do some maths on power dissipation and divider ratios and see what I can come up with and see what I think about it. Alright, so I did a little bit of math. If I use two 2.2 kilo ohm resistors like shown up there, so one going from there to ground and one going back to the feedback network, the dissipation across the two would only be 1/4 of a watt. Now my resistors that I'd be using in this case would be 1/2 watt metal film. So actually this is not a problem. So let's do it. I've got some wire here. What I'm going to do, because I've got, remember our audio ground is 10 ohms off main ground. So I'm going to run another wire from here, which is 10 ohms off main ground. That's essentially the star location for the audio ground, if that sort of makes sense. Well, technically the star location for the audio ground is right there off the end of that 10 ohm resistor. Yeah, you know what? I'll run my wire there. Why not? Why not do everything as perfect as it can be? So I'll attach a wire to that spot on each board, and I'll bring the wire over and I'll solder it to, yep, you guessed it, the provisional pad. And then I'll take this resistor off and I'll replace this resistor with a 2.2k resistor that goes from there to there. And then I'll put an additional 2.2k resistor from there to there. Excuse me. Now, if I'm doing that, we're going to need to change the capacitor values too, and I'm going to want to put that 1. Oh, you know what? Traditional millicompensation doesn't have the bump in it. So, because this is going to be a mixture of the two, I need to think about this for a sec. Sorry, guys. I think I'm going to leave the 1.4k resistor out. Let's just have a look at that picture quickly. What did they do? Now I don't see it in there. All right. First capacitor is still bigger. Now I'm going still for my compensation value, my C comp, Miller, whatever you want to call it, it's 47 picofarads approximately, right? That's why I've got a 470 in series with a 47, because it works out to about 47 picofarads still. It acts like a 47 picofarad capacitor, or close to it, right? And the ratio is high. Let me do the math on the new values and see if I've even got them. If I don't have them, what I'll do is I'll just use ceramic or mylar or something else. And then in a week or so, when the polys arrive and all the other stuff that I've got arriving, I'll just upgrade everything then. But at least the values will be in here to start working with. All right. If I was going to do that, I would need basically what was there, 120 picofarad and 100 picofarad, something like that. I'd probably go with 82 and 150, which incidentally is two of the values I ordered, and that's why. Or even 82 and 220. But anyway, I'm getting carried away. Because nothing's right, and I don't like doing things that aren't right, I think what I'm actually going to do, I'm going to take this resistor out, this 560. I'm going to take this 470 picofarad out, and we're just going to put a link over it, leaving just the 47 picofarad Miller cap in there. Not connected to the feedback path, and just one Miller cap. That way I can get the amp up and running, work on other things, get it as good as I can get it, and then when all my parts arrive, then we can hone in on this one circuit and really, really play with it. And because the rest of the amp will be, performing as good as it can by then, because I've had time to work on it, it'll just be a better way of doing it. I mean, that is the way you are supposed to do things anyway. when you design an amp, you're supposed to make it as good as you can make it and then close in feedback and stuff like that, right? So let's do that. Let's take out the 560 ohm resistor. Let's take out the 470 picofarad, bridge it over so it's essentially just a 47 picofarad across the VAS beta enhanced base to VAS transistor collector, and stick some power in this thing and get it up and running and see what we've got for gain and all that sort of stuff. Yeah, should be fun. I hope I haven't confused anyone going over all that, but I'm trying to be thorough. I'm trying to do a very good job here, and like I said, I plan on doing a lot of experimenting with this, and I want to do it properly, so let's not do half-assed solutions that aren't right, even if it does work. If it's not right, let's just leave it out for now until it's perfect. So with those out, if I just bridge across there and there, wait, is that right? Sorry, there and there. I just put a jumper across those two spots. I will have my normal compensation back. So that's what we'll do. That's the first one, yeah. Oh, what did I just do? That was the wrong one I took out. Oopsie. Oh, it's here. Yes. I'll take out the ones off the other board off camera, because I've already done a lot of soldering on camera making these boards up. But I'll leave all these components in a bag off to the side, because in a week or a week and a couple of days, I'll have a whole load of other components here to upgrade stuff on here, and once all that's done and I'm finished playing around with this, those parts and the poly caps that I've just ordered, polystyrene, will be getting played around with. Like I said, we'll hone in on this compensation circuit and actually try different techniques. Alright, I have taken the parts out, they're all here, and I've just put temporary links over it because it is temporary. So just thinking, ready for power up now for this. All I want to do is power this up and just verify that I've got 4 milliamps on all the current sources. If that is the case, I will check a couple of voltages. Although actually no, there's not going to be any point because the feedback side's not connected, so it's all going to be to one rail anyway. Yeah, no, I'll just power it up, make sure all the current sources are banging out 4 milliamps, and if that works, then I'll hook a wire onto that audio ground end of the resistor. I will hook a wire onto ground on each side, join those 3 wires together, hook some power wires onto it, bring an output stage over, hook that up and stick some power into that, see how it's working. Obviously on a current limited power supply, it's still going to be a bit of a problem with all these capacitors, because you've got the capacitors in the front of the power supply and then you've got the capacitors on the board. So if something does go wrong, there will be some peak inrush current for the output transistors and everything to see. So we just have to be careful and hope everything works. But yeah, let's do it. Alright, I'm actually going to end the video here. It's actually getting quite long, and now that I'm not just doing boring soldering, I don't want to make the videos too long because I want you guys to be able to take in everything and understand what's going on. Plus I've still got more stuff to do in this video, so I'll leave hooking this up to the output stage and putting the thing together for the next video. I've got this entire list, don't forget, of stuff. Should be telling myself not to forget, really. When this is built and up and running and I'm happy with it, we're going to investigate all these things, like 10 picofarad capacitor from the VAS collector to ground, safe operating area protection, VU meters, speaker protection, buffered input, linear regulators for the input circuitry, power rails, output inclusive 2-pole compensation, better current sources, or should I say references for current sources, maybe a mixture of both, and that 1.4 meg resistor that's across the compensation C2 cap. Does that still have an effect? Is the value that's optimal no longer 1.4 meg now that it's output inclusive 2-pole compensation? All this has to be investigated. So we've got, you know, when I said that there's a lot of stuff coming up to be done on this, there's all this plus another bunch of components to get swapped out because I've found better components. So still a lot to come. Alright, well, before I end this video, I think what I want to do, did I just adjust that? I want to make sure I have everything running at 4 milliamps on each current source. Particularly the VAS, because I don't want to hook this up to my output stage and have some sort of crazy bias current flowing. Just bring some power over here. 1 minute. Alright, so I'll just clip one lead onto the positive rail, one lead onto the negative rail. Let's see, do I need the bottom ground rail? Don't need the bottom ground rail, just the top ground rail, because it's part of the reference circuit for the current sources. Where can I hook onto that? Okay, I found a spot. So that's going to be my ground. I'll hook that to ground. That's positive. This is negative. Alright. Now what I'm going to... Wow, I can't believe I did that. Shut up. Now what I'm going to do is turn the power on and hope that smoke doesn't come off of my board. Okay, well that is already a really bad sign. Jesus. What happened here? Okay. Let me just bring all the voltage up. How much currents is pulling? Overall current. This is not good. That LED is really bright, that's really dim, and these two are off. I mean, what the... I don't even understand how this isn't working. Jeez. What? What on earth have I missed? I don't understand how I've mucked up current sources. Well, gonna have to do some troubleshooting on this. find it interesting that, oh, what the hell? Ah, my input section's not, yeah, I think it's just the input section. If I tie the feedback side to 0 volt, let's see. I think the input section's not drawing any currents at all. Still don't understand why. Oh, because the VAS is drawing more or less current. Okay, yeah. No, I think everything's actually working right. Let me just hook this 15K here. Bring it over to ground. Yeah. Oh, yeah. Well, it's only on one channel. So, yeah, that's what's wrong. All right. Let's start testing the current sources and let's just verify that between, say, negative rail and the output of each current source, we've got 4 milliamps. So on the multimeter there, we've got 4 milliamps. Can you guys see that? All right, 4 milliamps. That's good. VAS transistor. Oh, that was not good. Oh, I probably just damaged the LED. I'm going to have to check that because I don't want the forward voltage to have drifted. I just hooked onto the wrong thing. What am I missing? Oh, it's here. No, something's terribly wrong here. Let's just check this one over here. Oh, I just killed that LED. Alright, something's terribly wrong with the VAS current source. That's really odd. Input 4 milliamps. As you'd expect. I am absolutely bewildered. Have I got the pin out wrong? Let me just look at my schematic for a sec. There's something that doesn't add up here. This is very odd. So, this is our VAS current source, and I mean, that's the base. Collector here should have 4 milliamps, right? The collector, yeah, I already touched that and almost popped the LED. I don't want to do that again. It's the exact same circuit. They're a mirror image. I mean, what? I don't for the life of me understand how that's not working. At all. I mean, I'm just bewildered. It's interesting that it doesn't change the VAS current source ever. Yet putting a signal through the VAS transistor does do something. So that's kind of weird. The only thing I can think of is this transistor. I must have the pin out incorrect. I mean, what else can it be? Wait. Have I got this hooked up wrong? Where on earth is power getting in from now? Oh, capacitor's okay. No, what? Oh, because the LEDs are hung off ground and the positive rail. Yeah, duh. Dumbass. Dumbass Dave moment. So, how much current's flowing to ground? Nothing. No current flowing, sorry, to negative rail, not to ground, to negative. No current flowing to the negative rail. What about when the input's tied, the feedback side's tied? What do I see, 4 milliamps? Yeah, 4 milliamps. So, this is not good. That means our fast transistor's not even running. Okay. I wasn't expecting this. I've got to say, honestly, I'm shocked, but I've got a feeling I know what it is. It's going to be one thing and one thing only, most likely. So, when I had to put the current source transistors in for the VAS, I had to bend the pins and swap the pin out on them. I've got a funny feeling that they're still the wrong pin out, basically. I'm just going to double check that there's no voltage across these transistors. There shouldn't be, but I can't be bothered trying to think about the circuit in my brain. It's just quicker to look, isn't it? Half a volt, half a B stick. Only thing I can think of. Is that the pinout's wrong. That's hilarious. With the LED there and everything in circuit, it can't recognize it. Oh, this sucks. God, I don't know what I'm going to do about this. What can I do? Let's see. 3790. I'm just going to get one out the drawer. See, 3790. Let's see what the pin out is on one of these guys. Only got 2 of them left. 2 of each. Wait, I ordered more of these like 2 weeks ago. They're going to arrive like tomorrow or something. What the hell? The button's dodgy in this. Yeah, now it's clicking again too. What the hell? I don't know if it came across on camera, but it had a very plasticky feel, like the metal wasn't ticking. Oh, you see that? That was weird. Anyway, red's emitter, green's base. So base, collector, emitter, collector, base. Emitter, collector, base. Oh, oops. Emitter, collector, base. So looking at it from the front, emitter's going to the resistor. Collector's going. You gotta be shitting me. Really? That's hilarious. It's round the wrong way. Emitter, collect, base. Emitters go in the middle, click this on the right. So it just needs to be turned around. Oh, that's infuriating. So I've just soldered them in the wrong way. That's all. Okay, so it's not as bad as what it seemed at first. When I first powered it on, it seemed like everything was absolutely ape shit, but in fact there was just no current flowing through the input stage because of no bias. And the current source transistors are just upside down. I don't need to rebend the legs or anything, I just need to physically turn them around. So, alright, I'm not going to do that on camera, I'm not going to even do that on video. I'm sure you guys have seen me doing our soldering. What I'll do tomorrow before I start recording is I'll just turn these around, I'll turn it on, make sure that it's actually working. If it's not working, I'll do a follow up on it, but I'm sure that that's what's wrong. It's kind of obvious. They're the wrong way around. Everything else is working. I'm sure when I turn them around, it'll be fine. All right, well, that concludes this video. I'm going to bed. Electronics. All right, guys. Thanks for watching. If you like my content, give us a like and a sub, and I'll see you all tomorrow.